QSLS, the problem we're attacking is that historically, when you're dealing with design, engineering design, and engineering architecture, you only have the ability to describe relationships within the design or within the architecture. So you have tools like UAF, and you have SysML, you have UML to capture those design effects and design relationships. But you have no way of actually measuring what those things are. You only can guess at the qualities, at the characteristics, at the business effects of what you're doing. So with QSLS, we've joined together AI with some matrix mathematics, and we've been able to now discover a way of measuring those types of relationships. So QSLS starts with the architecture viewpoints: hardware, software, deployment, integration. Those are traditional architectural viewpoints. And we do a linguistic correlation between that and the various mechanisms that we're going to be using to describe the architecture of the system. And if we get down into design, we do the exact same thing. We take the viewpoints against the design mechanisms. When you run those correlations with AI, you get a value between 0 and 1. And that value for each one of those mechanisms is a level of support of that mechanism for that viewpoint. That's the beginning point within QSLS. Quantitative system level of support. Basically, the approach is I can define and select out a set of mechanisms or standards that I wish to deal with in my architecture. And then once that's done, I can then tell it to run a computation. And once it will go through, it will run the computation against it. It will store it in an external file, which I've pre-allocated. And then I can look at that file and I can see the actual values of the computation, and I can see the plotting of the data. And we plot and we compute and plot minimum, maximum, average, and median for characteristics, or actually we do the calculations for system types which relate to characteristics. And then from the system types, we can calculate the characteristics. We then run the characteristics against the quality attribute sub-attributes. That calculation is done. Once that's done, we can then use the output of that calculation to build up the quality attribute values. And then the third thing it does is it takes those sub-attributes and runs them against business drivers, and through a correlation matrix against business drivers, and produces out the values for level of support of each of the individual business drivers.